Signs of the roots. We have positive signs, then that is positive roots, negative roots, then roots of opposite signs, then roots equal in magnitude but opposite in sign. So likewise, we have four types. What do you mean by roots? By roots, we represent alpha, beta. Both roots are positive. Both roots are positive. That is, alpha and beta are positive. If alpha plus beta, that is the sum of roots, alpha, beta, the product of roots, are positive. It means what is alpha plus beta? Minus b by a in terms of coefficients of the square of the variable, that is x squared and x. Then c by e. So these are positive. B and C are of opposite signs, and C and A are of the same sign, right? So when B and A, when they have opposite signs, naturally it becomes positive, is it not? For example, minus of minus B, okay? And this one is A. Otherwise, minus B minus A. Then it results positive one. Got it? And what about C by A? C by A, that is both C and A should have the same sign. It means either it should be C by A positive or minus CA minus divided by minus A. That is, you are able to get positive. Do you understand this? These are the possibilities of getting the positive roots. Is it clear? Next, negative roots. Alpha and beta both will be negative when, that is, alpha plus beta is negative and alpha beta positive. Okay, it means minus b by a is negative, c by a is positive. It means a, b, c are all of the same sign. Then the third possibility, roots of opposite sides. It means in this case, alpha beta is negative. That is, C and A are of positive, opposite nature. Opposite signs. Then the fourth one is roots equal in magnitude but opposite in sign. It means alpha plus beta is equal to 0. That is minus b by a is equal to 0. It means bs is 0, right? Then only we'll get minus b by a is equal to 0. So it means for all real solutions of the signs, for all real solutions, the signs of A and C should be opposite. Now let us discuss about the common roots also. Then we will discuss some problems based on these two concepts. Common roots. To find the condition that two quadratic equations may have one root in common. And the second aspect is take down. Let us take the first one. To the condition that find the condition that two quadratic equations may have one root in common. So this is one aspect. Another is to find the condition that two quadratic equations of one may have both roots common. Let me explain. Let us consider two quadratic equations. Quadratic equation 1, that is represented by ax squared plus bx plus c is equal to 0. Another quadratic equation, let it be distinguished by a prime x squared plus b prime x plus c dash or prime is equal to 0. This is another quadratic equation. Quadratic equation 1, quadratic equation 2. Now, alpha be the common root. For both of them, the common root, because one in common. So the common root is alpha. Then, so when you have got this a common root, that is alpha for both the quadratic equations. Now the a alpha squared, b alpha plus c is equal to 0. A alpha squared plus, we can replace this x by alpha. B alpha plus c is equal to 0. That is, this quadratic equation becomes a alpha squared because alpha is a common, and similarly here this becomes what? That is a dash alpha squared plus b dash alpha plus, then you have got the c is equal to z. So this equation becomes like this. Do you understand why? Because we have got the common root alpha. So I am replacing this x by alpha. Now solving by the rule of cross multiplication. Solving by the rule of cross multiplication. We get alpha squared divided by this b c dash minus b dash c is equal to alpha divided by ca dash minus ac dash ac dash, that is equal to 1 divided by a dash, that is ab dash minus a dash b. Let me expand this further. Let me explain this rule of cross multiplication separately. Okay. Let us consider, that is, we have got this a x, even instead of prime you can put a1 also, no issues. a1x plus, and then b1y plus c1 is equal to 0. This is quadratic equation 1. a2x x squared, and sorry, x. This is not quadratic equation. I am simply representing two equations. a1x b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. This is second equation. Okay. So here, what are the coefficients of x, a1 and a? What are the coefficients of y, b1 and b2? Similarly, the constants are c1 and c2. So actually, this can be, the rule says, take down rule, x divided by b1 c2 minus b2 c1 is equal to y divided by c1 a2 minus c2 a1, that is equal to 1 divided by a1 b2 minus a2 b1. Okay. Now, how you can get this? Let me explain. For example, let me consider this as a1. Let us consider only a1, b1, etc. So put a1, a2, then b1, b2, and then c1, c2, right? Okay. And again, you have to repeat. Listen to me. The same should be repeated here. That is A1, A2. Now listen to me carefully. So here B1, C2 means you can multiply, cross multiply like this. Okay. Follow me carefully. So B1, C2. Whenever you do the multiplication, you get the negative sign by rule. So this goes upward, B2, C1. So what it becomes? B1, C2 minus B2, C1. You got this clear? Then let us take this one. C1, A2. This is the way you can easily arrange this rule. Okay. I'm just giving you an idea. Now listen. C1 into A2, right? Yes, sir. And the upward is minus. So C2 minus A1. Okay. Done. So that yes, we have to. And again, what you are supposed to do, you have to repeat this A1. Then you can take B1. The next one, B1 and B2. Now listen to me in the third one. That is A1, B2. You got this one? Okay. I'm just guiding you how to remember this, right? And now I am doing the upward one. So minus A2B1. You got this point? Now what you are supposed to do, that is you are writing this as a subtracted one, and in between that you can put X part, Y part, and this is one. Simply write one. Okay. Now we can rewrite this using this strategy. Now what is that? You can ignore the first part, start from the second part. Okay, so B1, B2, C1, C2, A1, A2. Again, you are repeating. Okay, now X divided by, do it B1, C2. Okay, B1, C2. And what is this? B2, C1 minus B2, C1. Got this point? Is equal to. And then what is this? Y. So Y divided by, what is that? C1, A2. So C1, A2 minus C2A1, C2A1. Okay, then that is equal to, and what about the third one? That is 1 divided by A1, B2 minus A1, B2. Okay, and this is A2, B1. Actually, this strategy is very helpful. This is called cross multiplication method, and this is one of the methods of solving linear equation. Do you understand? The same thing can be applied for quadratic equation. Got it? Now, can you see instead of writing a1x, what you are supposed to do? You can put ax squared, bx plus c is equal to 0. That is quadratic equation 1, right? Second one, a prime x squared plus, what is that? b x, b dash x, b prime x, and then c dash. So instead, now we are replacing this x by alpha. So you can call it A1, what is that? Alpha squared. B1 alpha. Got it? So likewise it goes. So can you repeat this? Can you apply this same strategy? That is this rule of cross multiplication to the set of quadratic equation that is in terms of alpha. Can you do that? Right. Also, can you show the previous page? So the same strategy can be applied in the quadratic equation also. I have done this here in terms of linear equation. So what you are supposed to do, you can take this a1x instead of a1x, you can write, for example, that is ax squared plus bx plus c is equal to 0. This is quadratic equation 1. And then a dash x squared plus b dash x plus c dash is equal to 0. So you can apply the same rule and evaluate. And as I already mentioned, instead of x, you can put alpha. You can replace because it is the common rule. Okay. Now, based on that, Let us proceed. So I have already arrived at this alpha squared. So alpha squared divided by BC dash minus B dash C is equal to alpha divided by CA dash minus AC dash is equal to 1 divided by AB dash minus A dash B. Okay. Now let us proceed. And let us see that is this alpha is equal to, take down, alpha is equal to BC dash minus B dash C divided by CA dash minus AC dash. Do you know how I have done? I have taken these two. Yes, sir. Okay. So I can take this here. So that alpha is cancelled here. So you got one alpha. So alpha is equal to BC dash minus B dash. Right? Similarly, you are able to get this one also. So here that is CA dash, right? This one. CA dash minus AC dash divided by AB dash minus A dash B dash. Okay. Now the condition is BC dash. You can multiply this. BC dash minus B dash C. Okay. Into this one. AB dash. You can cross multiply. AB dash minus, that is B dash A. B dash A. I think I have made a mistake here. That is, it should be A dash B. Okay. Yes. A dash B. So it should be AB dash and A dash B. Okay. Then into, that is equal to, these two can be multiplied. That is C A dash minus AC dash. Both of them are common terms. You can put square. Okay. So this is the condition for what? For this common root. That is alpha. You got this point? Yes, sir. Right. So please make a note of it. This is the condition. This is the condition to have common alpha. That is a root 2. Now let us proceed with the next concept. That is to find the condition that two quadratic equations. Second one. To find the condition that two quadratic equations of one may have both roots common. Both roots common. So what do you understand from this? Now here, yeah, that is, let us have common roots are alpha, beta. Okay. So in this case, alpha plus beta, that we know, the sum of roots is nothing but minus b by a. And the product of roots we know, that is c by a. From the second equation, second quadratic equation. This is from the first one. Second, what is alpha plus beta? Instead of b by a, you can write b dash by a dash, right? Got it? And alpha beta is equal to what? C dash by a dash. Got it? So it means, that is, this b by a is equal to minus b dash by a dash. Take down. So this minus b by a is equal to minus b dash by a dash. And these two, that is c by a is equal to c dash by a dash. So it implies that is you can rearrange. For example, you have got this a, you can put the a here and b dash here, right? So a by a dash, got this point? A by a dash is equal to b by b dash, right? Similarly, you can write, you can bring this c here and it becomes what? C by c dash. Got it? So if it is the case, then you can say that condition is achieved. So likewise, we have got two important conditions. Now let us discuss some problems based on this. Later. For which value of k, for which value of k will the equations, that is quadratic equations, x squared minus kx minus 21 is equal to 0 and x squared minus 3kx plus 35 is equal to 0 have common one root. Now let us assume the common root is the common root be alpha, right? So we can write down the equation alpha squared minus, and what is that? K alpha, got it? Minus 21 is equal to 0. Similarly, alpha squared, that is the second equation, minus 3 kx, 3 k alpha plus 35 is equal to 0. Okay. Now we can apply the rule of cross multiplication. Okay. So by the rule of cross multiplication. So what you can do, that is you've got alpha squared and alpha. So how you are supposed to do, you can put that is alpha squared, okay, and then alpha here and then 1 here. What you're supposed to do, you can put in between, you start from here, that is second term, that is minus, take down k, right? And what about this? Minus 3k. And in between that, you can write minus 21. What is this? Plus 35. And again here, that is 1, 1. And again here, that is minus k and then minus 3. Are you able to follow? Now what you are supposed to do? Cross multiply. And when you cross multiply, you have to introduce negative sign, right? So cross multiply and introduce negative sign. Cross multiply, introduce negative sign. Okay. Shall we write? So what is this? This is alpha squared. Let me write in a separate page so that it will be comfortable for you. Okay. Can you tell me what is that? Yes, sir. Yes, alpha squared divided by minus 35k. Very good. Minus 35k. And this is already minus or plus. Minus or minus plus. And that's what 5. Very good. So 63p. Okay, is equal to. And then this one. Alpha divided by minus 21 into 1. That is minus 21. and 35 into 1, 35 minus 35. Okay, why? Because upward. Then what about this one? 1 into minus 3, you can put minus 3 and minus of minus plus k. Good. K. Okay. Now from this you have to evaluate. So you can compare these two. Okay. So in that case, what happens? That is alpha, right, is equal to, you can bring this here. What is that? Minus 35, minus 35k minus 63k. How much? 98, huh? 98. Yes, sir. 98k. Divided by minus 56. Okay, got this. So it means how much? Um, that is a 7k by 4, right? 14 times. So 4. Okay. So 7k minus of minus plus. So 7k by 4. This is alpha. Okay. And from the last two, right? So from the last two, now what you can do? That is minus 21 minus 35. How much? Minus 56 divided by, and what is this? Huh? Minus. Just a minute, just a minute. What you have put, we have left that 3k, no? You must put 3, right? 3k. Yes, sir. So minus 2. So 3k. So minus 2. Minus 2k, right? Okay. Is it not? 3k minus 2k. So it means how much? Minus or minus plus. So 28 by k. Got it? Yeah. Got this? So you have got now alpha is equal to 7k by 4, and that is this 7k by 4 is equal to 28 by 4, not this one. Okay, so because 7k, we can equate these two because this is also alpha. So we can put 7k is equal to, what is that? Divided by 4. Now once again you can cross multiply. So 7k squared is equal to how much? 4 into 28. Therefore k squared is equal to 2 into 4. Okay. So k will be equal to. Okay, so k will be, just a minute. This is 4 into 28, not 4, right? 4 into 28. So 4 into 4. So it means k is equal to 4. Got it? It means plus or minus 4. Are you able to follow? Now you are able to get the value k is equal to plus or minus 4. This is the solution. So do you understand this? Okay. So let me repeat. What is the strategy here? They are given two sets of quadratic equation that has they have common one root, that is alpha, and we need to evaluate this k. So for which, what is the major strategy we apply here? We go by the rule of what? That is cross multiplication. Okay, rule of cross multiplication. Got this right? So this is the easy way you can proceed. Instead of, remembering alpha, A, B, C, you need not worry about this formula hereafter. You can do it yourself by fixing these coefficients like this. Okay? Yes, sir. It's a kind of determinant technique, but in advance I have taught you. Yes. Okay. Now let me proceed with the next one. Next sum. Now, if x squared plus px plus q is equal to 0, and x squared plus qx plus p is equal to 0. They have a common root. Okay. Show that p is equal to q, or 1 plus p plus q is equal to 0. Can you try this sum? Yes. See, we have got the common root, that is alpha here. Let us replace alpha, I mean x by alpha. So alpha squared plus p alpha plus q is equal to 0. That is the first quadratic. Second quadratic equation, that is alpha squared plus q alpha plus p is equal to 0. So this is the first equation. This is the second equation. So what you do is, that is, our objective is to find out the alpha. So what we can put, that is a 2 minus alpha. Equation number, subtract equation 2 from 1. Okay, that is equation 1 minus equation 2. You can subtract so that you can eliminate the alpha squared. Is it not? Right? So minus, minus, minus. Yes, you can strike. And what is this? Alpha being common, that is minus p minus q of alpha, right? And similarly here, q minus p is equal to 0. So you can change this as what? That is p minus, this is p minus q, right? So p minus q, and you can change this like p minus q of alpha minus p minus q. Am I right? Is equal to 0. Okay, got this? So this p minus q, right, being common, and p minus q of alpha minus 1 is equal to 0, right? Okay, p minus q of alpha minus 1 is equal to 0. So let us put q minus 1 may be 0. And if q minus 1 is equal to 0 means, I mean, alpha minus 1 is equal to 0 means alpha is equal to 1. Are you able to follow? Now we can substitute here so that you are able to get uh, the alpha. You can put it in the first equation. Okay, and since p is equal to, we have to show p is equal to q. Okay, so in that case, p minus q, one of the terms may be 0, therefore p is equal to q, right? Okay, now we can substitute either of this, therefore we can put it here. That is, when alpha is equal to 1 means what? 1 plus p plus q is equal to 0, right? You can take this equation. So 1 plus alpha is equal to 1 already. So q plus p is equal to 0. So we have shown both. Okay. We can substitute this in here, in the second equation. Okay. Stop doing the process. No need, because this alpha square can be easily cancelled. No, our object, when they have got two different coefficients, then you can try with that. Okay. So try to do this exercise that I have already sent to you. And if there is any doubt, you can ask me. Okay. So can I just conclude?